Okay, mass 100 kilograms is dragged up a smooth slope which makes angle A with the horizontal. So this is angle A here. And what we're quickly going to do is we're going to do a quick triangle here. Tan is opposite over adjacent. That is 4 over 3. Then we do the hypotenuse. So it's going to be this means cos A is 3 over 5 and sine A is 4 over 5. Okay. Now, thing to notice about weight is weight always acts directly down. So what I'm going to do is I'm going to over exaggerate this. So there's your particle going up the inclined face, and here it is going across and down. Now, just like projectiles, this here is going to be angle A. Now, your weight is 100 g because mass is 100 kilograms and weight equals mass times gravity, which is 100 g, which in turn is 980 newtons. Okay, now we're happy with that 980 newtons. That goes directly down. Now, the reaction force R perpendicularly up. So basically, this is all in one line. This yellow line here is opposite to this green line here. Okay, so the yellow line, which is R, equals the component of weight that's acting down in this direction. Now, this is going to be 980 cos A, and this is going to be 980 sine A, and sine A can be denoted by the blue part. Okay, now what I'm trying to explain here now is you're going to do 980 cos A, so it's 980 times 3 over 5. 980 by 3 over 5. 588 newtons. Okay, that's 588 newtons downwards. Because the block isn't sinking into the ground, it's only sliding up and down, this means that R is equal to 588 newtons. Now, this is not really significant because there is no friction in the first question, so we can park this off and use it later on. Next thing we got to do is 980 sine A, so 980 times 4 over 5, which is 784. This here is 784. Opposite. 784. Now, here's the good news now, 784 newtons, right? Now, it has a pulling force of 984 newtons up the hill. You draw a line here, and this is 984 newtons. Now, call this for argument's sake, I'll find another colour to use. What have I not used? Yeah, right? Now, the pink line going to the right is parallel to the blue line going to the left. These forces are acting against each other. The weight is causing it to go down the hill, while the pink line is causing it to go up the hill. The overall movement is an acceleration uphill, parallel to the slope. Net force equal to 984 take away 784, 200 newtons. 200 newtons equals ma, mass times acceleration. So what we have here is 200 times 100a, mass times acceleration, and divided across, and a equals 2 meters per second squared. Love my maths today. Now, what we're doing next is we're going to abandon this. We're going to keep most of our workings here. But what's going to happen next is in part B, I'm going to have to put in my own, I'm going to have to put in friction. Okay? Now, friction opposes the motion. So if we're getting pulled uphill, friction will act downhill. Like so. And if I choose another color to use. I'll go for yellow. Oh, yellow's already in use. Excuse me, I have to use something else. Let's go for an orange color. And so purple brings it up the hill. Orange and blue are going to bring it down the hill. Let's find out what our friction is. Well, our friction is 1/3 R. Is our friction force. This is friction here. R. 1/3 R. And we know that it's 1/3 588 newtons. 588 divided by 3 is 196 newtons. 196 newtons going downhill. Let's find out what our net force is. Net force. My toddler is banging his head against the window. Now, our net force is 984 newtons. Take away 784 newtons because that's what's going downhill, and the 196 is also going downhill. So this results in a number of, going for here, 984 minus 784, take away 196. And that results in only 4 newtons of force dragging it up. So the net force is 4 newtons. And this 4 newtons then, you can say is ma. Mass times acceleration is, mass times acceleration is 100 newtons, I believe. Mass times acceleration is 100a because mass is 100, and that equals 4. This means acceleration equals 1 over 100. 1 over 100 is 4 over 100, which is 0.04.